Hello, QST readers, ARRL members, and others who are tuning into the ARRL channel. I'm Dave Kassler, amateur radio call sign KE0OG, and am the author of the Ask Dave column in QST every month. In the April issue, April 2022, I mentioned that it is possible for a trap on an antenna to be just a coil and yet still be resonant. So what I did was I picked up this coil right here. This is an old, ancient, air-wound coil with little, the wire, it's all wire-wound. It's one piece of wire. The wires are quite close together, although not touching. There are air gaps between them. So if they were truly magnet wire and had an enamel covering, you could get them even closer to each other. But the thing to notice about this coil is that the definition of a capacitor is when you put two pieces of metal near each other. And so there is capacitance, not very much, but enough, capacitance in here so that this by itself will resonate at a frequency. Now, if you're going to make a trap, you're going to probably use magnet wire, and they'll be enamel coated, and so you'll wind those leads right next to each other, which will increase the inductance. As the inductance gets longer for the same amount of wire, the inductance goes down. As it gets closer, it goes back up. Okay. The number of turns goes up, it adds to the inductance. And as the area here goes up, then the inductance goes up too. So how do we determine if this thing actually has a natural frequency where the inductance and the inductive reactance and the capacitive reactance match, which would make this a tuned circuit, and it could act as a trap? Well, I've got my old MFJ 259B, my much beloved antenna analyzer. And so what we're going to do is use the dip meter adapter for this. This is from MFJ, and it has been around a while. It's the MFJ 66 dip meter adapter. And what you can do with this, by various methods that it shows in here, is find the resonant frequency of a trap or something like that. And there's all kinds of other things that you can do with it here. Okay, so we're going to use that adapter, and that adapter is this right here. It's just a little simple coil, and it goes into the antenna analyzer just like that. Okay, so on the theory that this has both capacitance and inductance, there should be a frequency at which this will resonate. And we do that by putting this into the middle right here and looking for a 1-to-1 SWR. So now we're looking at the SWR needle down here. I'm going to move this kind of sideways. And we're looking at this needle right here. And I'm going to go up slowly in frequency. I already know kind of where it is. Look at that. Look at that. There is a spot where you get SWR very close to 1-to-1. And look what the impedance is. It's very close to 50. Okay, this is at 62.869 megahertz. So that is the self-resonant frequency of this coil. Now, if you wind the coil differently, it'll have a different self-resonance frequency. You want to, for example, if you're building a 2040 trap dipole, you want the trap to resonate at 20 meters, or like 14.15 megahertz or so. Okay. Now, you could put the coils quite a bit closer together. You can expand the area Okay, you can do lots of things to make that work. I've got some magnet wire on order. When I get that in at the end of the month, I'll give this a try. But let's just take this out, which is going to mess up the readings. But I want to come down on this so we can see what we're looking at here. And I'm going to put this back in the coil. Okay. And we're going to get this thing down just as far as it'll go. There. Practically down to 1 to 1. Whoops, it did hit 1 to 1 there, didn't it? Okay. Now, R is 52. Resistance 52 ohms. X is 2, so there's very little reactive part. The SWR is 1 to 1. Over here, and you can see where it's a little past 50 ohms. Okay. Now, what is happening here? All of the energy created by the antenna analyzer is going into this coil. Okay. And the stray capacitance that it has created for itself there. And, oh boy, it's real touchy. All of the energy goes into the trap. It's trapped. It won't go any further. Now, if you were to put this in series with the antenna wire, then that would mean that since this is resonant at that point, it has a very high impedance and won't let anything past on 20 meters. On 40 meters, since it's below the frequency of resonance, it will create it'll act as though it's an inductance, and it will help load the coil, which will shorten the 40 meter part. It also increases the Q on 40 meters, so it won't cover the entire 40 meter band. I just wanted to show you that an actual coil has enough stray capacitance in it that it will self-resonate. Now, this particular one resonates at 62 megahertz, okay? But if we wind it tighter or with more area or more turns or whatever, we can go all the way down if we want to 14 megahertz and create ourselves a very simple little antenna. Now, I looked for formulas for determining the inductance of a coil just from its basic parameters. Couldn't find anything in the amateur literature, but there are some things available on the internet for that sort of thing. So there you have it. It is possible for just a coil of wire to act as a trap because of the stray capacitance between the turns. And so a trap consists of a resonant circuit that's both an inductance and a capacitance. And when in series with the antenna, it acts as a very high impedance, high voltage, low current, okay? And it will not let the 20 meters pass, but it will let the 40 meters pass, if that's the type of antenna we're building. So until we next meet, 73.